We're going to talk about digital twins. We're going to talk about autonomous networks and how does that all fit together. Why is it important? How can you start? Is it rocket science or maybe something you could have done starting 10 years ago, like SES has? But we're going to look at what can you learn and give you some takeaways if you want to go that route. I have two fantastic experts with me today. That's one, David Villegas from SES and João Antunes from Celfocus. Good, before we start, maybe a few words about yourself and your company. David, you want to start?
Of course. So I'm David Villegas. I'm leading the digital architecture department at SES. This is where we are thinking how we better provide services to our customers, what are our capabilities. And yeah, we'll explain a bit more about SES in a second.
Okay, perfect. Thank you. João.
Hi, so I'm João Antunes. I'm head of autonomous networks at Celfocus, so where we help customers providing help with roadmaps towards more autonomy of operations of networks, also using data, AI, ML insights, and so orchestrating as well, so they have better efficiency at operating their network.
Perfect. So Lisbon, Luxembourg, Munich. My name is Andy Waldenspiel. I have the pleasure to moderate this in my day job. I connect the dots. I work with vendors and operators on stuff that is defining the future, and digital twins is definitely one of those topics. David, you have brought us a few slides on what is SES, in case anybody does not know what SES is. Yes, you have an Astra dish on your roof, or maybe had one in the past, but this is not your area of business, right? So tell us about what is the cool stuff you do at SES.
So SES is a satellite connectivity company. We distribute content through satellite, but also provide connectivity to networks. We have a unique position. We have a multi-orbit, means that we provide connectivity through geostationary and medium orbit. We are the unique satellite connectivity provider with medium orbit. At the moment, we have more than 45 satellites in geostationary and 28 on the medium orbit. For those who are not familiar with the orbits, very quickly. So this is the typical spectrum of orbits. Geostationary is a satellite that is staying in the same relative position to the Earth. On the other, the advantage I would say is you can have full visibility of one side of the Earth, and there is more latency to go to that. More time it takes to go to the signal from the surface to the Earth because it's 36,000 kilometers away. And the other one advantage is that it requires less terrestrial infrastructure because with a few gateways you can provide connectivity. On the other spectrum is low orbit, let's say low latency, but the challenge you require way more infrastructure on the ground, and the latency is not that consistent because you have the jitter, the variability of the latency will change. The sweet spot, and that's why we decided to go, is the medium orbit. I think it gets benefits of both. It's low latency, it's good for real-time applications, very stable jitter, very, let's say, reduced amount of infrastructure we can do in one hop, connect one continent to the other. And that's a representation of a medium orbit fleet that we have. It's high throughput. That means that we can reach 1.5 gigabits per second in one single link. It's very predictable. Again, the jitter is very constant. You know always how the network is going to behave. And we provide flexibility to our customers. What does it mean? If the customer needs more capacity, we can increase the capacity. We can have bandwidth pools. Customers can switch capacity from one side to the other. Obviously, to manage this type of fleets, we use digital twins. We have been using that. Yes.
Second.
We have been using that for long, right? So having a digital twin of our satellite, so we can simulate. And as more as you are increasing your fleet, it ends up you have more complex systems, and the digital twins play a more important role. We talk about that later. We have been 40 years this year. This is the 40th year of SES. 40 years of success. We have provided content distribution, as explained. Many of you will have seen the satellite dishes at home connecting to get television channels. So that's one part. The other is the data services, where we provide connectivity. to different scenarios. And here is a representation of the different use cases. So we connect customers that are moving, right? Like cruises, airplanes. We connect oil rigs, infrastructure, critical infrastructures of nations. We support the governments, again, for mobility, and we support the emergency response scenario. Those are very common cases of our customers that they might need digital twins as well to know how their ships are working, how their oil rigs are working, or how the emergency response teams are, working on to support a natural disaster. That's a case I'm particularly proud of, and we'll talk a bit more later because there is a collaboration with Celfocus on that area. With that, I just want to mention that the interoperability is one of the major aspects to consider, right? Because it's not only about having a digital twin, how this data goes into these digital twins, right? So how do we interconnect with customers, with partners? And what is the role of the people? That we're going to talk also about that. The people dimension, it's very important as well. And with that, I think I have enough. I'll pass the...
Perfect. Thank you. Already great applause for you. And João, give us a few words about Celfocus.
I'll be very quick. So Celfocus helps our customers going into their autonomous network journey, essentially helping them with roadmaps. What's the architecture, what's the solution landscape would look like for them to increase their operational efficiency, but also to be more efficient while managing the networks, not only satellite, but also RAN, transmission core, and of course end-to-end in an end-to-end perspective. And of course, as we are also very believers of the network digital twin as a catalyst of this autonomy, because for you to be able to provide real-time intelligence, real-time decisions on top of a network, you cannot afford to be going and getting information from the network, from fault management, performance management, whatever it is, because the information is sparse, and this is one problem for a long, long time in operations. And so we really believe in this thing, which is how to create this virtual representation of the network, so that you can then put AI, machine learning, whatever it is, that can extract information in real time and do the decisions, so that you can either call someone or just automate it. So yeah, we believe that this will bring us a lot of use cases which provide a lot of value for operation, but not only for planning as well. How do I build my network? What if scenarios? We will talk about that. So yeah, a lot of scenarios on top of this, which we believe that bring a lot of benefits to CSPs across the board. So
great.
Let's
thank you, João and David, for setting the scene. So you saw already several industries benefit from this. You have media and telco that probably you are from, but there's government, there's emergency response. That's a use case you both are working on. We're going to explore that in a second. But before that, let's do some myth busting. So digital twin, it sounds super, super fancy, something very new. Who has one at home by chance? One at least. Is digital twin just a fancy word for simulation? Is there more to it?
It's a real thing. It's been done always, right? We have been always, whenever you build, you have a infrastructure, you are monitoring that is working, right? And you're receiving data, you need to take actions, you need to control to operate. So digital twin is something we have had for years. In the satellite industry, it's very common, as I explained.
Yeah.
But also the networks, right? The typical monitoring systems for the NOCs, the network control center, the customer support centers, they do that, right? So I think it's a nice word, but we have been doing it since always.
Okay. And we talk about autonomous networks. So why would the government have an autonomous network? What's the benefits? Just very briefly. Is it just cost, or is there other elements to it? Why would I want that?
The point is, we are going about in an era that everything needs to be connected. We cannot just afford that networks are going down, things are failing, right? So basically, the aspect that we're tackling here is how do we operate those networks in a smooth manner, and in a way that the networks end up taking action, self-healing, or we can manage the networks in a more autonomous way, more efficient way. So this is where the digital twin plays a role, right? It's not only about observability of the network, but it's also about how the network will react and identify when there is additional loads, reshape, and potentially in case of anomalies, how will self-heal.
Okay. I think there's also another aspect, which is when, well, typically we have a lot of observability within several domains of network, but there's also the need to how are my network domains interacting with each other, right? Because my network is not only composed of a RAN domain or a transport domain or a core, it's rather the stitching of those three and how services are going on top of it. So I think this network digital twin is also giving us the possibility of having that federation of the domains and having information from the several domains of network and information. So
I think that's a really good point, because when we were talking about satellite connectivity, it's not only the satellite, we have also terrestrial networks, and goes even deep into the customer network, right? So when you're monitoring, you need to interconnect all the different players, and it's multiple. At the edge, we can be deploying 5G, for example, network. Basically, we need to monitor absolutely all the different elements, and it's, as you said, right?
It's creating this ecosystem, visibility ecosystem.
So is this something that's like for the future, coming in the next 5 years? It's a digital twins simulation of a satellite you have since a decade. But that autonomous network in combination with digital twins, is that something really new? What use cases have been deployed, and then let's also talk about what are you working together on?
I don't think it's a new thing. Our customers, for example, they are digital twins of oil rigs. They are digital twins of cruise ship. For the emergency response, same thing, right? It's not. I think that's an important aspect. It's not only a digital twin about the infrastructure. Sometimes you need a digital twin about the people that are working on an emergency response case. You need to know where that they are deployed, how they are collaborating. That makes the action more smart, right? So I think it's a reality. Now it's how we make it more efficient, more accessible, and how we leverage new technologies. And I think that's where Celfocus plays a role, right? Because there are new technologies that we can leverage to accelerate this adoption, or to make it smarter, if you want, right?
Exactly.
This network.
So how to represent more information out of this ecosystem, like David is saying, this is not only how your network is doing, but rather how whoever is interacting with this ecosystem is also behaving or positioned or whatever it is. For instance, in disaster relief might be something that is very important is how people are moving on the field. And exactly like David is saying as well, which is how newer technology, cloud technology, better processing, newer database types or different types of databases can help you build this data ecosystem for AI to process in real time.
So let's talk about the use case, the concrete use case you work on. Give us a highlight of what is it and why does it matter?
So one of the use cases that we have been implemented by now is how you do the service impact assessment. For instance, you might have a planned intervention and you want to understand, okay, so I have this node that will be down. What is the services or customers that will be affected, and how and which time? So so it seems like an easy job, right? But most of the times you need like a very good topology, how services are connected to the resources and so on. So we do that with the topology, and with the digital twin, it's possible for us to understand, even with redundancy, to understand what are the exact impacts out of a planned intervention that is happening on the network. And so that helps us a lot, reducing that time to understand, for operations to understand and communicate to their customers that something will happen. And so it's about setting the expectation as well with their customers. So that's one of the use cases. Root cause analysis as well. So how do you go from a services that is misbehaving, because you now have machine learning to detect anomaly detection, to do anomaly detection and check when some session is not behaving as you would expect, and then you go from the session to the actual resource that is having the problem. So this is the big two use cases that our customers are requesting within fault management, change management are the process that they really look for.
And is it, obviously because the networks are more complex because there are multiple players, right? So we have, in SES, we provide satellite connectivity and some terrestrial connectivity that is supported by telecommunication companies. At the edge, we also have equipment. So basically, we're gathering data of the different operators of these respective domains, putting all that together. I think that's where, you know, the machine learning, the pattern recognition helps. All this interoperability and the standardization of this interoperability plays a role, and we are leveraging standards for that to ensure that the data can be collected, that we have all the visibility, and then you start, you know, doing all this machine learning, right? That's the pattern recognition. So observability being one. There is a common problem that is being faced by many telecommunication companies is that you have systems that maybe are too traditional, not leveraging AI, and start creating false positives. Yeah. And then your controllers are focusing the time on, you know, oh no, this is not an error. Oh no, this is not, right? You spend a lot of time on managing, you know, the system that is not behaving properly, it's not efficient. And here what we're trying is remove all that part, allow that the customer operation center is focused on value-added activities. So how they end up not wasting time on, you know, correcting the system, but getting valuable information from the system, right? So, and then getting proposals, as you say, troubleshooting, right? So this is the root cause of the problem. This is the action we're recommending. Do you accept it? Okay, yes, fixed, right? So that's kind of the way we're going, and you know, the solutions that you're building, I think, go into that direction.
Absolutely. So this is it. So instead of, we want to change the mode of operations, right? It's not looking at dashboards, looking for problems, red, green, amber. It's more about how we filter the noise out of the network, how we correlate all the information and say, this is what's happening. And then, of course, AI, machine learning, and even Gen AI can help you. And this is what you need to do about it. So this is the exact importance of it, because otherwise you cannot get operational leverage, right? So it's if your services are growing on top of your network each time, so more services, more people using broadband and so on. So how do you scale? How do you get operational leverage? It's exactly about it.
So it sounds fantastic, right? So you all want it, but it's not that easy, right? Let's talk about the challenges. Why is that? Why does not everybody have that already? Let's talk about what are the hurdles, what do you need to do to prepare to get there, and how do you cross the hurdles? So what's the biggest challenge in all this?
I think that there are two that I think are very relevant. One is the interoperability between all the different players. Gathering data from different sources, from different companies is difficult. All the manufacturers provide their metrics their own ways, proprietary, but you need information that is kind of standardized. So that's why the role of standards and interoperability is very important. That's what we are targeting, and we are communicating every time we have the opportunity. It's like, let's go all to the same standards, because that creates value to our customers.
Is there already a standard, or you're trying to define one?
There are some of them. Okay. We have a MEF, a TM Forum, these standardization bodies for telcos. We can leverage that. And I think that as more as we are facilitating, we contributed in SES to the standardization of the service performance metrics of MEF. They were in an initial stage to drive, but to say, no, we need to accelerate that, and through our partners, will kind of contributed to accelerate the closing that standard.
Okay, so standards interoperability is
that's
one.
The other is about people. Yeah. So what I see very often, right, in different companies, is that you have on one side the people that is expert about certain technologies, AI. They have the monitoring tools, very good, they can do. But then you have the customer operation center people that they are facing the problems. They don't know what I can do, but I'm just overloaded with managing the network. It's a lot of alarms, and this cannot be. I need to do something, but I don't have time. Then you have the network experts of the different domains. In our case, satellite networks. All these people together, doing a kind of a tiger team. Join forces and have a multidisciplinary team, and then start working on what is the major challenge we need to fix first, right? It's in incremental steps, right? And then start showing the value of these technologies. Very often, what I see is difficult is we think, this is too complex. Let's start thinking about it, let's start planning, and then you're kind of lagging, while others maybe are speeding up. Or you are not seeing, okay, I'm going to have to invest a lot. you know, is it going to give me the return I expect? Start small, put the people together, collaborate, start showing value, and run, right? It's really possible.
I mean, you might face the problem that you, in your company, your core is not AI systems and building digital twins. I mean, you did it in the past, but that's not what is your day-to-day business. You can train all your people, it will take, or hire them, and it will take time. But you don't have time in today's world because your competition is moving very, very, very fast.
It is.
How do you solve that?
So here is by partnering, right? You can, as you said, you can then start learning about AI, start learning about what are the possibilities, or you can go to the market, find a partner, like say, hey, I've been doing that, I have a solution, I have the knowledge, I've been implementing that with other companies, and we can accelerate the knowledge transfer, which I think is very positive.
Yeah.
And then start showing results. I agree. We have the tendency sometimes to wait and do it ourselves. We are an engineering company. We like to do things ourselves.
Yeah.
I am an engineer. I know more than any other engineer.
Engineers, hands up.
So, and your way is not the right one. It's my way, right? But no, look, we can work together. We can team up and leverage what's available. And then, of course, there's going to be areas for innovation that are new. Let's explore that, but let's leverage what is already available, and we can benefit today.
And this is what we see from customers as well. So most of them want the way of interaction would be also not for us to deploy like a black box, but rather to create a collaboration, a solution that they understand, that they can even manage or operate on their own. And so creating like a very open ecosystem where they can really operate it, evolve it, and that's how we collaborate. It's not only about also the solution, it's about how we change the mindset of the people that work on top of it to be more agile, to what solutions are there, what clouds, what tools, or what open source tooling that I can use to achieve this particular problem without, you know, falling into the typical pitfalls of implementing such technologies, because there will be a lot of data, which is one of the challenges that I add to the ones that you add, which I perfectly agree. But if we think about, it's not only representing the network, it's what is it? It's measuring it, right? It's faults. It's time series metrics. So there's a lot of petabytes of data, even that go second in second, and you need to from that data, you also need to understand and to be proactive rather than reactive to a fault or a problem that the network is raising. We need to understand first where the pattern is going down or wrong, right? So we need to go into that proactive mode and raise a red flag.
Yeah. So, is there a problem, or sometimes it's perception as okay, I work with a partner or vendor that and it's a black box and I'm totally dependent. But you said if you do it collaborative, open communication, so it's the way of working that will make the difference. I mean, is that something that you were originally maybe a bit concerned about? That okay, we give this out to an outsourced partner, but then we don't build knowledge?
Yeah. In some areas, obviously, right, there's always this concern, especially when it's an area that is a differentiator for the company. But what we're talking here is not a differentiator, it's already there. And telecommunication companies are using it. My view on that is let's use what is available. The collaboration, you know, I always see a partner approach, right? How we work together to solve this problem, right? And then is this knowledge transfer. I like what you say about the existing technologies. We're talking about things that are done for long. For example, all the recommendations you're getting with your content distributors at home, right? You see any movie and they will provide you real-time recommendations. Same when you do search in the internet, right? You're gonna get recommendations. All of that is based on the same technologies. Yeah. And it's well known, right? So we can apply these technologies to the network, right? So the only thing we need is people that know the technologies and people that know the domain, right? The domain experts, you know, how to apply those technologies to a specific case.
So looking at our title, the network digital twin as a catalyst, I might say that Celfocus is the catalyst to get it running, right? Is that a bit? They help to speed up.
I think that yeah, you have the knowledge and the domain expertise, and then we'll have the cases, right? And we can. There is obviously in the satellite communication industry there are some specificities that you need to know, right? And I think that combined in this area, it's a very strong.
And we also have a very particular approach, which is we do not, this requires a lot of different skills and roles from people to be doing something that it adds value to the end game and to your operations. So this means like you need cloud engineering, you need people to understand data science algorithms, but also the telco data. What is it that we are seeing as attributes? Is it the temperature of a certain box, or what is it? So how to interpret that data is important. So the way we tackle is also about that. So what skills and roles needs to be on this project, on this solution, so that we can add value in the end?
I think it's the exposition to the different companies and different cases, because when you have people that is domain expert, apart of knowing the technologies, it's easier to communicate also with the different engineering teams, right? You have our network teams that we know how the networks behave, how the satellites behave, what to look for. But then teaming up is easier communication. That's what I think brings the acceleration.
Yeah.
So we have a few minutes left. Let's talk about takeaways for the audience. So if they go home, where should they start? They say, okay, great, I have data like Oof goes digital twin up tomorrow. Where is the right point to start other than talking to you? What would you recommend them? What's important? What are the do's and the don'ts?
My suggestion is to start small, find a challenge that you are facing, and bring a team, multidisciplinary team together and prove the value. Because very often it's difficult to convince, we need to invest on that area, we don't know where to start. Let's start with, find the right people and start working on it. Please try to get people that have already done it, right? Let's start reusing. This is economies of knowledge. Let's start reusing the knowledge that is available, the experience that is there, right? And then later on you can be focusing on what's next, which are many different things for next iterations as well.
João, what would you say?
Fully agree. So the way we approach it is similar. So what we typically do is we say, select a use case. Typically our customers now are more on the fault management, change management use cases. That's where they want to go further down the level of autonomy. And so it's about choosing the right thing that is hurting the most, and then doing what we call an offline POC, which is don't care about integrations, don't do that. First, get the data into your platform, apply the machine learning algorithms, do the right ontologies, modeling of the things, then see what you can get from your data. If it has quality, if it produces results, and then if it goes well, yes, connect the pipes of data and then just let it run and provide value to operations. That's, I would say, is a very good way to start.
Because otherwise you might find that it's GIGO, garbage in, garbage out. So probably the first thing is make sure you have clean data, because otherwise it will be very, very messy. We have 1 minute. Is there anybody with a question? Otherwise, you find the two gentlemen here for a few minutes. Celfocus at the booth, just straight down the hall. There's, I think, some little port wine bottles left. So just in case the show is over soon, so go pay them a visit. Otherwise, big applause for the two gentlemen here. Thank you for coming, and have a great rest of Anga and safe trip home.
Thank you. Thank you for coming.